Hello everyone, we're going to go ahead and do our exam 1 review for our Math 120 class. These are going to be important questions that will look very familiar to you on the exam, so I wanted to make sure to go over some of them before your exam. So let's go ahead and get started. For our first problem, we have a Venn diagram. We're going to answer some questions about it. So we'll use the Venn diagram to answer the following questions. We have 4 parts of this. We have problem A, we have which set cannot be found in a Learn NC office. Then B, which sets have 4 legs. C, how many sets are animals. And D, what characteristics do humans, dogs, and lizards not have? All right, so we're going to go ahead and answer these questions in our notes so we can kind of write along with our problem. All right, so here we are with problem 1. So we're starting with A, which set cannot be found in a Learn NC office. So first off, this whole not found in a Learn NC office, we need to find the attribute found in a Learn NC office, and then we'll figure out which one is not included with that. So if we look at our Venn diagram, we see that the found in an NC office is right here, or Learn NC office. So that is the attribute that we see. We see that it is included in 2 of our sets, our lizards and our humans. We see that for both of those circles, it is included in both of those. So the one it's not included in is the one that it is not located inside. So dogs would be the only set that is not found in a Learn NC office. So we can fill that in, dogs. All right. Then we have which sets have 4 legs. Probably just figured this out from the get-go, but we do see that there is an attribute in there for has 4 legs. It is found right here. So we say, what sets have 4 legs? Well, it's going to be in the 2 sets that contain that attribute. So it's definitely in the lizards set, and it's in the dogs set. We do know that humans do not have 4 legs, so that establishes, definitely confirms our answer. So which sets have 4 legs? Dogs and lizards. All right. Then see, how many sets are animals? So we can look at our Venn diagram and see where the attribute of animals is. And if we look, it's right here in the center, animals. We know that the center of a Venn diagram usually is going to mean all sets. And we see that dogs, humans, and lizards circle around that attribute animals. So therefore, it would be in all sets. And there's 3 in this case. So how many sets are animals? 3. It's really all of them. All right, then lastly, what characteristics do humans, dogs, and lizards not have? So basically, we're asking now, what do none of them have? And if we look here, we do have the Venn diagram. It is contained within the universal set, and there are a couple extra attributes in there. There's have fins, can breathe underwater, and can fly. We probably know that humans, dogs, and lizards don't have those things. So when we say, what does it not have, we're really looking for what is within the universal set, but not contained within one of the circular sets. So all of the attributes listed on the outside. So what characteristics do humans, dogs, and lizards not have? They do not have fins. Can breathe underwater. And can fly. We're asking what they don't have, so we don't want to write don't have fins, don't breathe underwater, don't fly. because we're already stating what they don't have. So they don't have those attributes. You just want to list those attributes. You don't need to add any sort of like negative phrasing to it. So, all right, we answered some questions based on our Venn diagram that was given to us. And then we have it. So that wraps up problem number 1. Let's go on to problem number 2. All right, so that was problem number 1. Number 2, you really want an iPhone 14 Plus for $1,200. So you traded in your iPhone 11 for $373.85, and you use it as a down payment. You signed up for 5 equal installment payment plan. So how much will you pay for each installment? So when we talk about things and we say down payments, we mean we're going to take that amount and deduce it from the original amount by saying, I'm going to pay a little bit now and then I'll pay the rest later. And in this case, in installments. So when we calculate our 5 equal installments, we want to subtract the down payment. So let's go ahead and do this all together. All right, so with problem 2, the first thing we need to really figure out is how much am I actually going to owe for this iPhone 14 Plus based on my installments, just 5 equal installments. So basically that means I need to subtract the value of my down payment from the value of my iPhone, or the new iPhone. So my new amount will be the original cost, $1,200, minus my down payment, $373.85. So I can go ahead and figure out my new amount. I plug it into my calculator, and I get that this iPhone 14 Plus is really going to cost me $826.15. So I can take that value and divide by the equal installments. So I'll take my new amount and I'll divide by the number of installments. So my new amount, which we said was $826.15. And I divide by my number of installments, which we said was 5 equal installments. Since it's equal, I don't really need to worry about any one of them being more than another. So equal, so divide by 5. So I plug that into my calculator, and I should get the value of $165.23 per installment. And there we have it. So in that case, we kind of set up installment planning based on how much we actually owed, which is going to be your original minus your down payment divided by the number of installments, which in our case was 5. So, all right, that wraps up number 2. Let's go on to number 3. So for number 3, instead now we're going to rewrite each set into the given form. So we'll be given a set and we need to change it into a different form of the set. So for part A, this is in set builder notation because we have our item and then the property of our item. So we have X, where X is a natural number and X is more than 25 and less than 30. So we can go ahead and list this in the roster method. Remember, roster method is just listing the actual values. Then in B, we have a roster method. We have our roster form. We have just the numbers 12, 18, 24 within curly braces. And then we'll write out our descriptive method. So we're going to just use the English language to describe our set. So let's go ahead and do these together. All right, so starting with A, we want to kind of transform our set builder notation into roster method. So we said X, where X is a natural number. So just to establish that X being a natural number just means it's going to be whole numbers that are positive. So We don't have 0 and we don't have negative numbers. So a natural number, like we're just not including decimals or fractions or anything like that. So it's a natural number, and we're saying it's greater than 25 and less than 30. If we notice here, there's no or equal to part. There's no, we see the inequality having a line underneath the mouth, the alligator mouth, however you want to think of it, the inequality. There would be a line underneath if it was or equal to. So we're saying it is very much greater than 25 and definitely less than 30. So in this case, we cannot include 25 and we cannot include 30. It would be all the numbers in between. So let's go ahead and list those out. When we do our roster method, we always want to write curly braces. We always want to include our list within those braces. So if we're starting with greater than 25, and it's a natural number, the next number would be 26. So we'll start at 26, and then we'll go 27, 28, 29, we stop there. Because we can't write 30, and the number that's less than 30 is 29. So we finish off our answer with another curly brace. So this set in set builder notation in roster method really just corresponds to the numbers 26, 27, 28, and 29. So once again, if those inequalities had the little line underneath, you could include the value of 25 or 30, but in this case, it does not. So you do not include 25 and you do not include 30. So, all right. Now on to B. We have the roster method set of 12, 18, and 24, and we want to find a way to describe this. When we use our descriptive method, as we know in just normal English language, there's lots of different ways to describe things that are still technically correct. And that is also true when it comes to these types of problems. When it comes to an exam, sometimes you'll be given options and multiple choice. We just pick the best option. Or sometimes you can just come up with them yourself. So when we come up with one, we just want to make sure that it's correct. And there could be many answers that are correct. And we just need to list one. So let's go ahead with what I think is the easiest one. So we have these numbers 12, 18, 24. So, all right, they're whole numbers, they're positive. We can pretty confidently say, okay, whatever it is, it's natural numbers. So with our descriptive method, let's say that first. Say X is a natural number. Or when we talk about the descriptive method, we describe the set. So we're going to say the set of natural numbers. So that's how we'll start. The set of natural numbers. All right. Now we can think of another way to kind of categorize our values. Let's go ahead and start with like that range of X, kind of how we saw similarly in the problem before. So we can say the set of natural numbers, and we have 12 as the lowest number and 24 as the highest. We just need to include a set that has those values. And we could even take note from part A and just make the first number one smaller than our first number in our set, and our second number just one bigger than the last number in our set. So if I want to talk about the set of natural numbers between two values, I want to go less than 12 and more than 24. And I don't need to go crazy. I can just pick one less and one more. So let's do that. The set of natural numbers, we're going to say greater than 11 and less than 25. So greater than the lowest number minus 1 and less than the highest number plus 1. So the set of natural numbers less than, start with the greater than, 11 and less than 25. Equivalent things we could have said is greater than or equal to 12 and less than or equal to 24. We definitely could have said that. That just would have been more writing. So Easily, definitely could have been those answers. You just would have had to write more, and this is still correct. Both options are currently correct, which one are you right? So, all right, we've set up that it's natural numbers. We set up that it's greater than 11 and less than 25. We set up the range. And there's one last thing, because if we just say the set of natural numbers greater than 11 and less than 25, that'll be 12, 13, 14, 15, 16, all the way up to 24. And we don't have that. We have 12, 18, and 24. So we want to think of one more description of these numbers that would allow us to really set up this set. And if we notice, 12, 18, 24, those are all divisible by 6. 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24. So that'll be our last description there. The set of natural numbers greater than 11 and less than 24 divisible by 6. So we'll go ahead and write that in. Another way of saying that would say multiples of 6 or anything along those lines. So once again, as long as your description accurately represents the set, it's really all that matters, even though there were probably like tens, maybe even 100 different ways to describe this set. As long as it is correct, that is what matters. So, all right, that wraps up number 3. Let's go ahead and go on to number 4. All right, number 4. Determine if each set is equal, equivalent, or neither. So we have 3 parts here. Part A, we have the set A is the set of odd natural numbers greater than 12 and less than 20. And B is the set of natural numbers greater than 18 and less than 23. And B, we have A is the set of natural numbers greater than 15 and less than 20. And B is the set of 16, 17, 18, 19. And C, we have A is the set of D, F, G, and B is the set of G, M, Q, Z. So for each one, we'll determine if they're equal, equivalent, or neither. So let's go ahead and do these together. All right. So for problem 4, part A, we want to establish what these sets actually are. First off, we want to remember what equal and equivalent mean. Equivalent means 2 sets with the same number of elements, not necessarily the same elements, just the same number of them. So if 2 sets have 4 elements, the elements do not have to be the same as long as the number of elements are the same. That would make it equivalent. If something is equal, it means they have the exact same elements, all of them the same and the same number. So really, when we talk about if something is equal, we always mean also equivalent. So if something is equal, it's also equivalent. That also means that something that is equal has to be equivalent. You cannot have something that is equal and not equivalent. So always remember that equal is also equivalent. You cannot have equality without having equivalency. Something can be equivalent, though. That means it just have that same number of elements. The elements do not have to be the same. And then we have neither, meaning they don't have the same elements and they don't have the same number of elements either. So just a reminder of what those mean. So when we do something like A, where we have A is the set of odd natural numbers greater than 12 and less than 20, and B is a set of natural numbers greater than 19 and less than 23. Okay, great. We have to go ahead and put these probably in roster method so we can see how many elements there are in each set and are they the same or are they neither. So let's go ahead for part A. We want to establish what each of these sets actually are. And we're going to list them in roster method. So we have A is the set of odd natural numbers greater than 12 and less than 20. Okay, so we're looking for whole positive numbers that are greater than 12. Cannot be 12, has to be more than 12. And less than 20, cannot be 20, has to be less than 20. We did not say or equal to. So between 13 and 19, essentially, and we're saying they're odd. So they have to be odd numbers, not even, not divisible by 2. Starting at 13, we get 13, 15, 17, and 19. And that is the set A. We're greater than 12, less than 20, and all the numbers are odd. Looks good. All right. B is a set of natural numbers greater than 18 and less than 23. So once again, greater than 18, meaning starts at 19, less than 23, ends at 22. And we just have natural numbers, no difference between like even or odd. So we'll list all those values starting at 19, 20, 21, 22. There we go. Greater than 18, less than 23. And we can see here that between the sets of A and B, A has 4 elements and B also has 4 elements, meaning that they are equivalent. The elements, though, are not the same. They share the value of 19, but other than that, they do not have the same values, meaning that they are equivalent. They are not equal. So we can write that in. Equivalent. They are not equal. All right. Then for B, we have A is the set of natural numbers greater than 15 and less than 20, and B is the set of 16, 17, 18, 19. So B is already in roster method. So really we just have to turn A into roster method and then compare. And then we see C is already in roster method, so we don't necessarily need to do anything really with that one. So for B, we want to turn A into roster method. So the set A, we said is the set of natural numbers greater than 15. So once again, greater than meaning 16, less than 19. So meaning we start at 19. It's less than 20, so we're going to end at 19. So between the values of 15 and 20, not including 15 and 20, what are the numbers? That would be 16, 17, 18, 19. And that is also the set of B, 16, 17, 18, 19. Same number of elements, same exact elements, therefore they are equal. Which also means equivalent. All right. Then for our last one for C, we have 2 sets. Move our work down a little bit here. We have 2 sets. A is DFG and B is GMQZ. All right, so the number of elements in A are 3, DFG. And the number of elements in B is 4, GMQZ. So they don't have the same number of elements, and they don't have the same elements either. So they have to be neither. They are not equal and they are not equivalent. So, all right. That wraps up problem 4. So let's go on to problem 5. We have a circle has a radius of 6 millimeters. What's the exact and approximate circumference and area of the circle? We're going to round to the nearest hundredth if we need to. So we have our picture here. We have our circle. We see it has a radius of 6 millimeters. So our circumference and our area of our circles have specific formulas where they both use the radius. So we'll be able to plug those in. So, all right, let's do this one together. All right, so for example 5 here, we've already stated that we have specific formulas for the circumference and for the area. So the circumference of the circle will be equal to 2 pi times the radius. This is also the same as being pi times diameter. In this case, we only have the radius, we don't have diameter. We could find diameter, but it's not exactly necessary, so we don't need to. One important thing that's always good to remember, though, is that 2 times the radius equals the diameter, which also means diameter over 2 equals the radius. Good things to remember. So we have our circumference of our circle should be 2 pi r, 2 pi times radius, and our area is equal to pi r squared. There is no equivalent version for area in diameter, although we could technically still plug in diameter. It would be diameter over 2 squared. So for area, it's best to find what the radius is first and then plug that into your function. We have two parts of this question. We want the exact and the approximate circumference. The exact calculations here means that you will leave it in terms of pi. So when we write this out, we'll have our circumference will be equal to 2 times pi times our radius, which we said was 6. We can simplify this by multiplying the 2 and 6 together, and this gives us 12 pi. And we leave it like that. That's what exact means leaving it in terms of pi. This is exactly correct. There are no roundings that would approximate the area. Now we can find, that was the circumference. Now we'll find the area. So the area we said was pi times a radius squared, which will be 6 squared. 6 squared is 36 times pi. So our exact circumference would be 12 pi, and our exact area would be 36 pi. Now, with approximate, it means we are going to actually plug this into our calculator and solve. So approximate values are what we actually plug into calculators. We already know that our circumference is 12 pi, but we're actually going to plug into our calculators 12 times pi. Then we were told to round to 2 decimal places. So we want to make sure to do that. So come out to about 113.10. One thing that was slightly forgotten here was to add back on our units. For circumference, we only have our radius one time, which means our units will be the same as the radius. So for our circumference, we would have 12 pi millimeters, or approximately 113.10 millimeters. Then for the area, we have 36 pi, which we will plug into our calculators and do 36 times pi, which will come out to about 113.10 will be the area. That is 36 times pi. That was an error on my part. So 36 times pi is 113.10. And when we calculate area, we took the value of our radius and we squared it, meaning that it will have the units of our radius squared. Same thing over here. This would be millimeters squared. Then for our circumference, which we said was 12 pi, 12 times pi in our calculator should be 37.70. That is the actual value of circumference and the area. You plug them into your calculators correctly. So there we have it. So always want to remember exact is going to be in terms of pi, approximate is actually plugged into the calculators and calculated out and rounding off to as many decimal places as you are being asked for. For us, it was the nearest hundredth. Just so happened that both of them ended with a 0 in this case. But there we go. So those are our answers for problem number 5. So let's go on to problem number 6. For problem number 6, we have that Layla is staining the wooden floor of a court. The court is in the shape of a rectangle. Its length is 51 feet and its width is 32 feet. Suppose each can of wood stain covers 102 square feet. How many cans will she need to cover the court? So in this case, we're covering the entire portion of this rectangular court. So if we're filling in everything within the rectangular shape, we're really finding the area. This is also indicated by the fact that the wood stain covers 102 square feet. Square feet is, or square units in general, is referred to as area or measures of area. So we need to find the area of the court and then see how many cans of wood stain that Layla would need, knowing that it needs 102, or it covers 102 square feet. So let's go ahead and do this one together. All right, so we have our court here. It's in the shape of a rectangle. We draw this out as best as we can. So here's the court. Maybe it's, basketball or probably something along those lines. So we have our court here. We're saying it's 51 feet long and 32 feet wide. So we really need to find the area of the court. Area, we say, is length times width, or L times W. We have that the length is 51 and the width is 32. So the area of our court is really going to be 51 times 32. They're both in feet in this case, so when we write our answer, it'll be in feet squared. So we'll go ahead, put in our calculators, 51 times 32, which should be 1,632 feet squared. So that's the area of the court. Now we want to know how many cans of wood stain that she'll need. We know that every can covers 102 feet squared. Of the court. So the number of cans she'll need will be equal to the area of the court divided by the area of the stain. So the area of the court we said was 1,632 feet squared, and the area of the stain is 102 feet squared. Now in this case, we're just finding a number, so our units are canceling each other out. And we'll divide 1,632 by 102, which gives us the value of 16. So there'll be 16 cans will be needed to stain the floor of the court. So, all right, that wraps up example 6. Let's go on to example 7. All right, for problem 7, we have the following information was for a 150-person survey. Use the table to fill in the Venn diagram, then answer the following questions. A, how many people only had nausea? And B, how many people did not have nausea or drowsiness? So we're answering these two questions based on the information in our little table that we're given. And we want to fill out the Venn diagram. These little lines there, so we need to fill it in. So our table tells us who had drowsiness, who had nausea, and who had both drowsiness and nausea. When we see the words had drowsiness, had nausea, we don't see the word only in there, meaning that those people or a specific part of those people probably have both. So we need to figure out how many people only had drowsiness or only had nausea, and then we can figure out how many people didn't have either by filling in our table, and then we can answer our questions. So, all right, let's go ahead and do this one together. All right, so for this problem, we want to fill in our Venn diagram first, and then we should be able to answer our questions pretty well. So if we start with our Venn diagram, we have had drowsiness, had nausea, had both, and then who didn't have any, so the universal set. And we have some information. We know that some people had drowsiness, some people had nausea, and some people had both. When it comes to filling in information into a Venn diagram, it's best to start in the both category. If you know how many people had both, you want to try to fill that in first and then work your way outwards. Of course, if you're not given that information, you have to do, what you can to fill it in. But in this case, we want to start with the middle. So starting in the middle, we have 39. 39 people had both. So our middle chunk in our Venn diagram will be how many had both, which was 39. 39 people had both. Now to fill in the sides, we're saying 67 people had nausea, 84 had drowsiness. So to figure out how many people only had drowsiness or only had nausea is we're going to subtract the number of people who had both from each category. So drowsiness will be equal to the number of participants, 84 with drowsiness, minus the people who had both, 39 people had both. So 84 minus 39 would be 45. So 45 people only had drowsiness. So we can add that number in there. Now we want to find the people who only had nausea. We said 67 participants had nausea. So we have 67 minus the people who had both, 39. So here we should end up getting 28. So 28 people only had nausea. So we'll fill that in there. Now we're almost done. The last thing we need to know is how many people didn't have any symptoms. That would be our universal set, or what's left over. And we were given this piece of information, 150 person survey. So we know that in total there were 150 participants. So our universal set will be equal to 150, the people in the entire box, even in the circles, minus the sum of all the numbers we've already written. Because we said 45 people had only drowsiness, 28 people had only nausea, and 38 people had both. So we need to subtract the sum of those numbers. So 45 plus 29 plus 28. So we're going to add those values together. Get 150 minus 112. 45 plus 29 plus 28 is 112. So 150 minus 112 leaves us with 38. So 38 people didn't have either symptom. All right, we filled out our Venn diagram. Let's go ahead and answer the questions. These should be pretty easy now. Part A, how many people only had nausea? Well, we calculated it. We said 28 people only had nausea. Then B, how many people did not have nausea or drowsiness? So how many people did not have either symptom? And we said that was 38. And there we go. So being able to fill out your Venn diagram on a question like this first will help you a lot with actually answering those questions. You should probably already have those answers by the time you're done filling out your Venn diagram. And you just need to copy those answers over. So just as a reminder, when doing Venn diagrams, it's always best to try to start in the middle first and work your way out. Although if you are not provided the middle, you will have to find some way to figure that out and try to find the middle before finding the rest. Okay, there we go. So, all right, let's go on to problem 8, our last problem. All right, problem 8. Use the graph to answer the following questions. A, which day had the most number of snow days, and how many did it have? B, how many more snow days did January have than March? And C, which months had at most 6 snow days? So we're given our graph here. We have days of snow, and then we have the months. So December, it looks like we had 2 days of snow. January, looks like we have 6 days of snow. February, looks like 14 days of snow. And March falls right in between the lines for 2 and 4, meaning that there's probably 3 days of snow. So let's go ahead and answer these questions all together by reading our graph. All right. So for problem 8, first part A, which month had the most number of snow days and how many did it have? So in this case, we're looking at a bar graph. We want to look for the tallest bar, which in this case was February. We have that this is by far the tallest one. And this is how many snow days it had, which if we follow the line, tells us 14. So February had the most number of snow days at 14 snow days. So February, 14 snow days. All right. Then B, how many more snow days did January have than March? So now we're looking at how many more than something else. So in this case, we want to figure out how many each have. January has 6 snow days, and March has 3. So if we want to know how many more snow days did January have than March, we can subtract. 6 snow days minus 3 snow days equals 3 snow days. So how many more snow days did January have than March? 3 more snow days. And lastly, which months, so can be one or multiple, had at most 6 snow days. So it's an important distinction here that we have these words at most. At most means the number given. So for us, we have 6. It's the number given or less. So if we have at most 6, that's the most I can have. I can have 5, 4, 3, 2, or 1, or even 0. Then the difference on that, which we don't have this here, but at the same time, at least means the number given or more. So it's important to know those distinctions. At most means 6 or less. So if we're looking for 6 or less, we said February definitely had 14, and that's way more than 6. So definitely not February. January had 6, which is fine. We said it's the number given or less, so 6 is fine. December looks like it has 2, and March had 3. So all those 3 months had at most 6 snow days, 6 or less. So which months had them? December, January, and March. So those were the months that had at most 6 snow days. So this is something that's important to remember, the difference between at most and at least. It can help you with these certain types of problems, just knowing kind of what it's asking you for. So, all right, that concludes problem 8. So that actually wraps up our review. So good luck on exam 1, everyone. I hope you found this review to be helpful. Don't forget to do your review assignment for exam 1 as well. And good luck, everyone.